Hello students, welcome again to my channel. In this video, I am going to discuss some shortcut methods or tricks to calculate the bond order for those molecules which are multiatomic and also show the phenomena of resonance. So, it is requested, please watch the video till end. Let us start our session. So, to calculate the bond order of the resonating molecules, there are two methods. So first method is the method 1, which is as the bond order is equal to 1 plus number of pi bonds upon number of sigma bonds. Okay, and in the second method we have the bond order is equal to the number of bonds between any two atoms in all resonating structures upon the total number of resonating structures. Let us take some example. The first example I am going to take here is the carbonate ions. So by using the first method, the bond order will be equal to 1 plus 1 upon 3, that is equal to 1.33. So the question arises, how do we know that how many number of pi bonds are there in this carbonate molecule and how many sigma bonds are there? So it is suggested that first of all you must calculate the hybridization of the carbon, that is the central atom. Okay, so we know that it is equal to the number of valence electron plus number of monovalent atoms minus the charge of cation plus the charge of anion. So the total is 6/2, which is equal to is equal to 3, that is hybridization is sp2. That means the structure is planar. Okay, now the number of lone pairs will be equal to n minus m plus d, that is equal to 3 minus 0 plus 3, which is equal to 0. That means in this molecule there is no lone pair of electron. So what would be the structure? It is the planar structure and there is no lone pair of electron, so one oxygen atom will be doubly bonded with the carbon and the other two oxygen atoms will be singly bonded or having the minus charge. So in this molecule there is 1 sigma, 2 sigma, 3 sigma and 1 pi bond. So the number of pi bonds are 1 and the number of sigma bonds are 3. So the bond order is 1.33. Okay, let us take the second method. The second method is the number of bonds between any two atoms in all resonating structures. Okay, and it is divided by the total number of resonating structure. Again the question arises, how could we know that this molecule is having how many resonating structures? So it is a simple rule. The central atom and the other atoms which are directly attached to central atoms, so we can easily predict the resonating structures. That means the number of atoms which are directly attached to the central atoms. So there are 3 resonating structures. You just see the number of atoms which are attached to the central atom. Okay, so there will be 3 resonating structures. It will be having one this structure, other will be the this, and one will be the this structure. So number of bonds between any 2 atoms, you can take any 2 atoms. I will take these 2 atoms. So structure A, structure B, and structure C. So what will be the bond order? It will be equal to the number of bonds between the 2 atoms in the first structures. It is 2 plus it is 1 plus 1. Total number of resonating structures are 3. So it is 4 by 3. That is 1.33. Very simple. Let us take few more examples. So I am taking the molecule that is sulfate. By the first method, we are going to calculate the bond order, that is equal to 1 plus the number of pi bonds. So there are 2 pi bonds and 4 sigma bonds. I am going to write down or draw the structure of this sulfate for your clarity. So just N, which is equal to half, valence electron 6, monovalent 0, cation 0, that is anion. Simply it is 8 by 2, which is equal to 4. The structure will be the hybridization will be the sp3, that is tetrahedral. The number of lone pair n minus m plus d, that is the 4, and this 4 minus monovalent is 0 plus divalent is 4, so it is again 0. That means the sulfur in this molecule do not have any lone pair of electron. So what would be the structure? It is going to have the tetrahedral structure just like this, and there is no lone pair of electron, so that means there will be the pi bonds. Okay, so the 2 oxygen atoms are going to have the negative charge. Okay, so this is sigma bond, this is a sigma bond, this is a pi bond, this is a pi bond, this is a sigma bond, and this is sigma bonds. So how many pi bonds are there? 1 and 2. How many sigma bonds are there? There are 4. So it will be having 1 plus 1 by 2, that is 1.5. Okay, let us use the second method. By the second method, the bond order will be equal to, yes, in this case there are 4 oxygen atoms which are directly attached to sulfur, so it will be having the 4 resonating structures. So these resonating structure will be the this, this, okay, and one more is the like this. no other structure can be drawn. So take any two atoms. I am going to take these two atoms. So how many bonds are there? 2. In this case again 2. In this case it is 1, and this case it is 1. So the bond order will be the 2 plus 2 plus 1 plus 1 divided by the total number of resulting structures. So 2 plus 2 4, 5 and 6, 6 by 4, that is 3 by 2, which is equal to 1.5. Okay, so you can take any number of examples. Let us take one more example, which is very simple. C6H6, that is benzene. So the structure of benzene is this, and its resonating structure is like this. Okay, the method 1 I am going to write first. So the bond order is equal to 1 plus the number of pi bond, that is 3, and the number of sigma bonds between the carbon, and that is equal to the 6. So it is equal to 1 plus 1 by 2, that is 1.5. In the second method, so the bond order will be equal to the number of bonds between the two atoms in all the resonance structures, which are equal to 2 plus 1 upon the number of resonating structures. So it is again 3 by 2, that is 1.5. I hope you people have find this topic very interesting and informative. So don't forget to like. In my upcoming videos, I am going to discuss so many shortcut tricks to memorize various concepts of chemistry. So those students who are new to this channel, please subscribe my channel, and yes, press the bell icon too. Thank you very much.